In this molecule right here, which of these carbons has more bonds? Carbon A, carbon B, or do they both have the same? So the correct answer is that they both have an equal number of bonds. Bond line structures for pure hydrocarbons only show carbon-to-carbon interactions. However, they still tell us a lot about the molecule, and no matter what, each carbon will have 4 bonds, as it's a marker of its stability. All 4 of A's bonds are with other carbons, and that's why we see them. But for B, of its 4, 3 of them are hydrogen and 1 of them is shown. Now, 4 bonds doesn't necessarily mean 4 attachments, which leads us into our next question. Which carbon has more attachments? Carbon A or carbon B? The correct answer is carbon B. This is because even though each form 4 bonds, A already has all 4 bonds accounted for, so it's not going to have any hydrogens and hence no more attachments. But for B, we only have 2 bonds accounted for. So to get to the 4, we have to add 2 hydrogens. So B has 4 attachments, A has 2. This also explains why every carbon within our question 1 molecule has 4 attachments. With nothing but single bonds, there's a 1-to-1 relationship between the number of bonds of each carbon and the number of attachments. Be sure to check out the video in the description where I go in depth with bond line structures. Question 3. Which of these molecules has more carbon atoms? Believe it or not, they have the same number of carbons. Carbons are the ends and the bends in bond line structures. So because each molecule has 5 dots, each will have 5 carbons. The only difference is that we go from 1 bend and 4 ends to just 5 bends. So with this, I want you to comment below. Which molecule has more hydrogens? Molecule A or molecule B?